Welcome dear all my students. In this class we are going to say about what is acceleration. Before that I have to tell one thing. This is the very much hard time because we are not at all meeting frequently. But in this communication tool only to some extent the knowledge transformation. Okay, I am telling from here and you are hearing from your home. But you have to interact very well with me. Then only you can catch the points what is given in this lesson. Okay, my dear students, you have to study well. That is the primary thing in this hard time. Okay, I feel so sad because you are in some other place and I am here, but there won't be any meeting place for us. So please, dear students, study well. This class will reveal you about acceleration. Previously, we have studied about the differences between the speed and velocity. In this class, we are going to study about what is acceleration. I'll tell you the definition now. Acceleration is the rate of change of velocity. In other words, you can say that if a body changes its speed frequently, the body is said to be in acceleration. Okay. Suppose if there is any change in the direction, then you can also say that the body is in acceleration. There should be change in two important things. One is the speed, the other one is the direction. You can say that, then you can say that it is in acceleration. Even if the direction changes, then you can say that it is in acceleration. Okay, now let us see these three cases. In the first case, to some extent, car moves with the speed of 20 meter per second. After that, it's 30 meter per second. Okay, it changes its speed. In the first half it is 20 meter per second, in the second half it is 30 meter per second. So there is a change in the speed. Then you can say that this body is in acceleration. Okay. Then now coming to the next case, here it is 20 meter per second to some extent. That is first half crossed by this body is 20 meter per second and the second part also 20 meter per second. There won't be any change in the speed at all. But there is a change in the direction. No. Even if the direction changes, then you can call it this as this acceleration. The body is said to be in acceleration. And now coming to the third case. In the first half it is 20 meter per second, the second half 30 meter per second, but the direction also changes. Here also you can say that the body is said to be in acceleration. In the equation format we can say that acceleration is equal to change in velocity by time. There should be two different velocities, is it not? Final velocity and initial velocity. You take the final velocity as v and initial velocity as u. If you subtract these two things, v minus u, then in the denominator you have to put time. A is equal to, the acceleration is denoted by the letter small a. Small a is equal to v minus u by t. And this equation gives you the definition for acceleration, is it not? Change in velocity by time. Simply you can say that change in velocity by time. Here the velocity is in meter per second now and the time is in seconds and meter per second squared. Already we are having meter per second. If the second comes down, then you may have 2 seconds, is it not? Meter per second squared. As a unit of acceleration is meter per second squared. Now coming to this problem, a car at rest starts to travel in a straight line path. It reaches a velocity of 12 meter per second in 4 seconds. What is the acceleration? Assuming that it accelerates uniformly, okay? They gave the car moves with the uniform acceleration. You take that the car initially at 0 meter per second. There won't be any movement at all. Then after that, the final velocity is v is equal to 12 meter per second. You know that the initial velocity u is equal to 0 meter per second because the car initially at rest. And final velocity is 12 meter per second. And what is the time duration given? It is 4 seconds. Then acceleration a is equal to v minus u by t. And if you subtract 12 minus 0 by 4, it is 3 meter per second square. What is the SI unit of acceleration? It is meter per second square, is it not? If you strike out 12 by 4, you will get 3 meter per second square. Okay, then see this cheetah. My name is cheetah. I can run at great speed, is it not? You know, cheetah is the fastest animal, fastest running animal, is it not? Do you know what my speed is? It is 25 meter per second to 30 meter per second. My speed changes from 0 to 20 meter per second in 2 seconds. See how good my acceleration is. Can you calculate it? They have given the acceleration 0 to 20 meter per second in 2 seconds, is it not? So 20 minus 0 by 2, what will you get? 20 by 2, then you will get 10 meter per second square. Now it is easy to calculate the acceleration. Suppose in your examination, if any data given, will you be able to calculate the acceleration? Yes, of course you can, because v minus u by t is the simplest formula to find out the acceleration. You have to notice the initial velocity and the final velocity, subtract these two and then divide it by the time duration crossed by the object. Then you will get acceleration. Okay. Now it is very clear what is acceleration, is it not? Now let us come to the other part, positive acceleration and negative acceleration. Positive acceleration and negative acceleration. Negative acceleration can also be called as deceleration or retardation. If the velocity of an object increases with respect to time, then the object is said to be in positive acceleration. If you consider the velocity according as the time increases, if the velocity also increases, then you can say that the body is in positive acceleration mode. And what is negative acceleration? If the velocity of an object decreases with respect to the time, then the object is said to be in negative acceleration or deceleration or retardation. You consider this example. Initially, the body moves with the velocity of u is equal to 8 meter per second. Final velocity of this body is v is equal to 2 meter per second. What is the difference between v and u? It is coming with negative sign and the time duration is 10 seconds. Now let us calculate the acceleration of this body. The velocity of a golf ball rolling in a straight line changes from 8 meter per second to 2 meter per second in 10 seconds. What is its deceleration? Assuming that it is decelerating uniformly, okay? Now let us calculate the deceleration. Initial velocity is 8 meter per second. Final velocity is 2 meter per second. Apply in the formula. Now you substitute these values in the formula. Acceleration A is equal to v minus u by t and 2 minus 8 by 10. If you subtract 2 minus 8, you will get 6 by 10. Then divide 6 by 10, then you will get 0.6. And note down the sign here, it is in negative sign, minus 0.6 meter per second square. So it is in deceleration. The negative sign itself indicates the body is in positive acceleration or negative acceleration, or you can simply say that in deceleration. Please observe this tabular column. We are going to study about uniform acceleration and uniform deceleration. Look at the time here, 1 second, 2 second, 3, 4 and 5 second. For each and every second, the velocity increases by 20 meter per second. Look at this tabular column. In the first case, it is 20, after that 40, 60, 80 and 100. Like that, the velocity increases uniformly. But in the second case, the velocity decreases uniformly. This is related to deceleration, but it is uniform acceleration and uniform deceleration. In the first case, for each and every second, the velocity increases by 20 meter per second. But in the second case, the velocity decreases 20 meter per second for each and every increase in the time. That is, if the time increases by 1 second, the velocity decreases by 20 meter per second. So that in the first case, you can say that the velocity is in uniform mode. In the first case, you can say that it is in uniform acceleration. But in the second case, it is in uniform deceleration. Now it is very clear, is it not? Now let us come to the next part, that is non-uniform acceleration. An object undergoes non-uniform acceleration if the changes in its velocity for every unit of time is not the same. Previously, we can say that it is 20 meter increasing, 20 meter per second increasing and 20 meter per second decreasing. But look at this tabular column here. Initially, the body is in a rest position. After that, for the first second, then it is 10. After that, 40, 60 and now the same, 70 and decreasing. Sometime it is increasing and sometime it is decreasing. But if you note down the changes in the velocity, it is positively increasing. Is it not? The change in the velocity here is 0, 10, 30, 20, 10, 20, like that. So that you can say that it is a non-uniform acceleration. The change in the velocity is not the same for every second, is it not? This is the important case you have to notice. I think you understand very well about non-uniform acceleration. I'll meet you with a super good topic next time. Please, dear students, study well, utilize this time properly, and improve your knowledge to your maximum possible extent. Thank you for watching.